Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. The acidity of substituted phenols depends on whether the substituent at the para position is electron donating, EDG, or electron withdrawing, EWG. EDGs destabilize the phenoxide anion, conjugate base, by increasing electron density on oxygen, making the phenol less acidic. EWGs stabilize the phenoxide anion by withdrawing electron density, making the phenol more acidic. Step 1. Identify substituents and their electronic effects. A. Paramethoxyphenol. The OCH3 group is a strong electron-donating group, EDG, via resonance, plus M effect. It donates electron density into the ring and ultimately onto the phenoxide oxygen, destabilizing the negative charge on the conjugate base. This makes it the least acidic. B. Paraethylphenol. The CH to CH3, ethyl, group is a weak electron-donating group, EDG, only through induction, plus I effect, hyperconjugation. It slightly increases electron density in the ring, mildly destabilizing the phenoxide, but its effect is much weaker than that of the methoxy group. C. Paraacetylphenol. 4-hydroxyacetophenon. The C is equal to O, CH3, acetyl, group is a strong electron-withdrawing group, EWG, via resonance, M effect. It withdraws electron density from the ring and stabilizes the phenoxide anion effectively, making it the most acidic. Step 2. Rank by acidity, most to least acidic. First, most acidic is equal to C. Paraacetylphenol, EWG by resonance stabilize phenoxide. Second is equal to B. Paraethylphenol, weak EDG by induction, mild destabilization. Third, least acidic, is equal to A. Paramethoxyphenol, strong EDG by resonance destabilizes phenoxide. Step 3. Why other orderings fail? A. Cannot be more acidic than B, because the methoxy group's resonance donation is far stronger than the ethyl group's inductive donation. B. Cannot be most acidic because the ethyl group, while weakly donating, still reduces acidity relative to C. C. Must be most acidic because the acetyl group's strong M withdrawal uniquely stabilize the phenoxide through extended conjugation. Therefore, the correct answer is A. 3, B. 2, C. 1. Therefore, the correct matching is A matches 3, B matches 2, C matches 1.